Hey everyone, today we're going to discuss about a deferred annuity. Now, a deferred annuity is an annuity in which the first payment is not made at the beginning nor at the end of the payment interval but at a later date. So, mostly we're going to deal with present value in the deferred annuity. And after you borrow, there is a space of time period before you can have your first payment. This time interval where you're not going to pay yet is what we call the period of deferment. The period of deferment is a time interval to the beginning of the first payment interval. Now, there are several ways on how we're going to compute for the period of deferment. If the first payment is due at the end of a specified interval, the formula is D is equal to M times K minus 1. So, D is equal to M times K minus 1. However, if the first payment is due on the next interval, the formula is D is equal to M times K. Now, the present value of a deferred annuity can be computed using the present value is equal to periodic payment times the expression 1 minus 1 plus I raised to negative n plus d all over I minus 1 minus 1 plus I raised to negative d all over I. So this one is the formula for the present value. We're not going to deal much with the future value of a deferred annuity because it's going to be similar with the future value of a simple ordinary annuity. So we're just going to have the present value of a deferred annuity. Let's have an example here. So find the present value of a deferred annuity on a regular payment of 1,000 pesos semi-annually for 3 years that is deferred for 1 year on a rate of 2.5% compounded semi-annually. So in this situation, let's say that we took a loan. So we have this particular amount of money, then it will be repaid after 1 year when it was borrowed. So the payment will be 1,000 semi-annually for 3 years and with a rate of 2.5% compounded semi-annually. So let's start first by identifying our variables. So our periodic payment is 1,000 and our interest rate per period is R over K, where our R is 2.5% or 0.025 divided by, that is compounded semi-annually, so K equals 2. And this is equal to 0.0125. For the N, we're going to have T times K. The time is 3 years and there's a payment of 2, which is semi-annual. T times 2 is equal to 6. Now for the period of deferment, we can observe in the problem that the payment is just deferred for 1 year. So we're going to start our payment after 1 year. So we're going to use the formula M times K because it occurred on the next interval. So this is 1 times 2, which is equal to 2. So these are the variables that we're going to use. For our formula, let's make our substitution. So the present value is 1,000 times 1 minus 1 plus I, which is 0.0125, raised to negative, this is n, which is 6, plus d, that's 2, all over 0.0125, which is I, minus that is 1 minus 1 plus I 0.0125 raised to negative d, that's negative 2, all over I 0.0125. Let's use our calculator to compute for this value. I would suggest let's start computing for this one, this value here. Let me underline it with a red. Yan, with red. Yan. Let's compute for this, then let's compute for this. Remember that during the course of while we're computing it, let us not round it off. So once we compute for this 2, we subtract them and multiply it with our periodic payment of 1,000. So our value would be 1,000 times, let's compute for this, that would be 0.0125 plus 1 raised to 6 plus 2 is 8, that's negative 8, then times negative 1 plus 1 divided by 0.0125, that is 7.5681242994 minus, let's just compute for the next one, that would be 0.0125 plus 1 raised to negative 2 times negative 1 plus 1 divided by 0.0125, that would be 1.963115379. So we have these values here. Let's subtract the 2 and multiply it with 1,000. So let's subtract, then multiply it with 1,000. The value that we're going to have is 5,605.01. So this is the present value of the money that we have for the deferred annuity. So for our next video, we're going to discuss about general annuity. I hope you guys learned a lot today, and see you guys on the next video.